this is Britt Caswell with another example video. In this video I'm covering example 1 from lesson 2-3, where we are starting to talk about factoring a quadratic expression. Alrighty, so the way that I start approaching this is we have to identify what kind of factoring we need to use. So if you notice on this quadratic, your a value, the number in front of x squared, is 1. Alright, this is a different kind of factoring, though not really, from this one where the a value is 2. Alright, and then here for this little a problem, the x squared minus 9, do you see that the b term is missing? So this one is called the difference of squares, which has its own factoring rule. Alright, so I'm going to use the same factoring method, which is called factoring by grouping, as these three, although I'm going to call this one the double bubble method, which you're going to see here in just a moment because it's faster. Okay, so when my a value is 1, I'm going to factor with the double bubble. When a is not 1, okay, I'm going to factor by grouping. When the b term's missing, I use a difference of squares, and then this one's also factored by grouping. So now we've identified what type of factoring we're going to use. So let's go ahead and get started. So for the double bubble, it starts with coming up with the idea of what factoring is. Alright? So when I am factoring something, I am breaking an expression that is all subtracted by addition and subtraction and turning it into an expression that is separated by multiplication. That's what it means to factor. Now with the double bubble method, which again you can only do when a is 1, I'm going to fill in an x within the first parenthesis. Okay, so step 1 on this procedure is fill in x in the double bubble. Step 2 is to fill in the signs. Okay, now there's a couple of things that we need to consider. I always start by looking at the sign in front of the c term. Okay, so if c is positive, you need to use the same signs. If c is negative, you're going to have different signs. And the reason for that is actually has to do with foiling. So if I wanted to revert from the factored form into the standard form, right, I would go about distributing the first parenthesis to the second parenthesis. And so to generate this last term, the 12, I'd be taking whatever is here and multiplying it by whatever is here. So in order to get a positive number through multiplication, your signs have to match. If this was a minus, then you would have to have opposite signs, because that's how you produce a negative number. So in this case, because it's a positive, I need the same signs. And I'm going to look at the b value to tell me what sign it is. Alright, so because my b is a positive, I'm going to have a plus and a plus. Alright, now step number 3 is to find the factors of c that, I'm going to leave a blank here, to b. And so here, the factors of c that add or subtract. And I do that based on the b value. Alright, so because this is a positive b, I'm going to find the ones that happen to add to it. Or no, I'm sorry, I do it based off the c value. Sorry, it's been a minute for this one. So because I need the matching signs, if this is a positive value, I'm going to add my two numbers to b. If this was a minus 12, I'm going to subtract the two numbers to figure out what equals b. And so what normally people do is they create what's called a t-table. Alright, so this is going to be the factors of c, so the factors of 12, and then they need to add, because that's adding, so that sum to b, which is 7. So I'm just going to start listing the factors of 12. So I have 1 and 12, I have 2 and 6, and 3 and 4. So then I'm going to go ahead and add them together. So 1 and 12 is 13, so that's not the set. 2 and 6 is 8, so that's not the set. And 3 and 4 is 7, so that's the set. And normally I take whatever the bigger factor is and I put it in this first set of parentheses, because I think about this as falling down. So I'm going to say 4 and 3. It doesn't really matter. It could be 3 and 4, because these are both positive. But there it is. Now, factoring by grouping works fairly similarly in a lot of ways. It just takes practice to see how similar they are. So let's talk about factoring by grouping. So the first thing is to multiply a times c and find what adds to b. Alright, so this is the factors of a times c. So a times c, so 2 times negative 3 is negative 6. And they need to sum to b. So they need to add up to negative 5. Now the tricky part with this is that negative here, because it creates a secondary list of factors. So for example, to get negative 6, I could have 1 times negative 6, but I could also have negative 1 times 6. So you see how I'm using the same two numbers, but I'm flipping where the negative is? I could also have 2 times negative 3, or negative 2 times positive 3. And then I can go ahead and add them across. So 1 plus negative 6 is negative 5. That's going to be the first. That'll be the one I end up using, right? Because it has the number. For posterity's sake, I'm going to keep adding these, though, so you see them all. So the one that matched was 1 and negative 6. So then I'm going to go ahead and split the b term with a plus in between. Alright, so I'm going to be taking this negative 5x and break it into two terms. So the a and c, those are going to stay the same. So I have 2x squared and I have a minus 3. But that minus 5x, I'm going to turn it into plus x plus negative 6x. Alright, so you see there's the 1x and there's the negative 6x. And if I combine those like terms, it turns into that negative 5x. Now it's important to note you have to have this plus between. So you notice how I didn't put plus x minus 6x? If you don't have the plus in between, it's going to mess up your signs and you won't be able to factor it properly. So now step 3 is to break into two sets of parentheses. So I'm going to do that. I'm going to put one set of parentheses here and one set of parentheses here. And I'm going to put the word added here so that you realize it has to have the plus in between. Okay. Step 4, I'm going to do it in another color. I'm going to call it factoring out the GCF. Okay, so I'm going to go to each set of parentheses and just pull out the greatest common factor. So here, between 2x squared and x, the GCF is x. That's what I'll divide out of both. Here, the greatest common factor between 6x and negative 6x and negative 3 is negative 3. So that's the GCF I'll pull out there. Alright, so 2x squared divided by x is 2x, and x divided by x is 1. Here, negative 6x divided by negative 3 is 2x, and negative 3 divided by negative 3 is a positive 1. Now, do you see that there's a matching set of parentheses? That's what you need, okay, for this expression. So then step 5 is to write as two parentheses being multiplied. Okay, one with the GCFs, and then one with the matching parentheses. Let me show you what I mean by that. So the parentheses with the GCF, I'm going to take the stuff that I factored out of these parentheses and write it out here. So this is x minus 3. And then I'm going to take this set of black parentheses that are there, and I'm going to write the one that's copied. And so this is the factored form. Now it's worth noting that this last step that we did, where all the yellow, or sorry, orange and black is, this is just factoring out the GCF again. Essentially, I'm factoring the 2x plus 1 from the entire expression and writing it out here. But I think that's a confusing way to view it. Alright, so there's our 5 steps. So I want to go through, and I'm going to do part B down here before I do the difference of squares, just so that we can see that process again. Alrighty, so step 1, I need to multiply A times C. Okay, so I'm writing that here. So I'm going to find the factors of 3 times 2, which is 6. And they need to sum to negative 7. Alright, now remember, with these factors, to get a positive value here, I have to have matching signs. Okay, so that means that to get a negative here, I'm going to have all negatives on here. So I have 1 and 6, but they both have to be negatives. And I have 2 and 3, and they both have to be negatives. Because if I did a positive 1 and 6, that would be a positive 7, and that's goofy. Or a positive 2 and 3, that would get me 5. See how those are coming out as positive numbers? So in order to get that negative and have my matching signs, I know they both have to be negative. So negative 1 plus negative 6 is negative 7, and negative 2 plus negative 3 is negative 5. So I'm going to be using this top term. Alright, so the second step is to split the b term with a plus in between. So I'm breaking minus 7x into minus 1x plus minus 6x. And remember, your a term and your c term, they stay as they are. Alright, so step number 3 says to break it into 2 sets of parentheses that are being added. So here's where I'm doing step number 3. Step number 4 says to factor out the GCF. Alright, so between 3x squared and a minus x, the GCF is x. Now, do you see how this set of parentheses has a positive and a negative, and this one has a negative and a positive? So that means that when I go to factor out this one, I'm going to factor out a negative number so that I can flip the signs, and the signs will match. Okay? And then between 6x and 2, the GCF is 2. So let's go ahead and actually, I don't need that plus anymore. Well, I guess the plus doesn't matter. I'm going to leave that plus there. Okay, so 3x squared divided by x is 3x, and negative x divided by x is negative 1. Negative 6x divided by negative 2 is 3x, and 2 divided by negative 2 is negative 1. Alright, and then step 5 is to write as 2 sets of parentheses being multiplied. Okay, so one of them is going to be the GCFs, and one of them is going to be this copied set of parentheses, or the matching set of parentheses, whatever you want to call it. So my GCFs were x and a negative 2. So there we are in the factored form. Now the difference of squares that we have for a here. Understand, when I'm talking about a difference of squares, okay, difference means subtraction. And squares is talking about when you square a number. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, so 4, is 16. Okay, that's the list of squares that we're talking about. Okay, so we have to make sure that the numbers involved in this are perfect squares. So like 1, 4, 9, 16, 25, 36, those numbers. So it might be helpful to you to have a list of squares available to you. And so what the difference of squares does, it says if you have a squared minus b squared, what you can do is you can break it into 2 sets of parentheses being multiplied. One where it says a plus b, so you take the square root of each number and put it in there. And one where it says a minus b. Okay, so the difference of squares is really quick to go ahead and factor. Now sometimes the difference of squares is masked. They will have a GCF that you need to pull out first. It doesn't happen in this one, but it happens pretty regularly. So make sure with any type of factoring that you always check for a GCF that you can pull out first, and then a lot of times it's easier to factor. Alrighty, so here I just need to identify my a and my b values. So the a term here, okay, a squared is x squared, so the number being squared is x. So where I have my a's in my sets of parentheses, I'm just going to write in x. And remember, one is a plus and one is a minus. Now my b, the number being squared to make 9, is 3. So where the b's are, I'm going to write 3. And that's our factored form. Alright, so there's some starting out factoring examples. Until next time.